Welcome everybody. It's a great pleasure to hold this webinar for you. But who am I? A short info on me as a person. My name is Franz Eder. I'm from the University of Innsbruck, and here I'm Associate Professor for International Relations, and I'm also the Dean of our Faculty of Social and Political Sciences. My research focuses especially on foreign and security policy, a little bit on counterterrorism, and especially on the United States, Europe, and of course Austria, and here especially also small states. I also do a little bit of research on social science research methods, especially quantitative text analysis or discourse network analysis. And I'm also teaching on academic writing and presentation and on open and reproducible science. And that's the reason why I'm here. If you want to learn more about me and what I'm doing, or if you want to get in contact with me, have a look at my website or write me an email. So what is the program of today's seminar? I will start with a short recap about the question, what is computational reproducibility? And I will talk about or introduce you to the reproducibility iceberg, as Rodriguez calls it. This is important because it's the basics, or it's important to understand these concepts in order to know why we should use renv and the targets package at the end of the day. So why are they useful? And so the main focus of this webinar will be on the question of package dependencies with renv in R, and the use of targets for pipelining. So how to build pipelines in R using targets. What is this? I'm going to explain to you soon. And at the end of this webinar, you will have plenty of time, let's say about 20 minutes, at least, for a Q&A. And I hope I can answer all your questions. Again, there's a Git. You can basically access all the files, all the scripts of this presentation. And you can also have access to the presentations as such as a PDF or as an HTML file. And if you clone this repository, you can do the same analysis that I will show you here in this webinar. So what are the learning outcomes of this webinar at the end of the day? So basically, after completing this webinar, you as a participant should be able to create a reproducible environment in R projects using the renv package. You should be able to adopt a function-oriented style of programming. What it is, I'm going to explain to you shortly. And you should be able to use the targets package as a pipeline tool for our projects. So it's a very basic introduction. I'm going to show to you also further books and tutorials to dive deeper into these topics. But basically, at the end of the day, you should have a basic conception or basic understanding of these packages and these concepts. It's quite ambitious for the 70 minutes. This webinar will last approximately, but I'm pretty sure that we will succeed at the end of the day. So let's start. Or are there any questions concerning the program and the learning outcomes? No questions? Good. So let's go on and start with the first point. What is computational reproducibility? Again, it is important to know this concept in order to understand why there is an added value for the use of the renv package and the use of the target package. So computational reproducibility is, as Kitz argues, and I really recommend this book of Kitz. It's an open access book, and it's a wonderful book about the practice of reproducible research from different scientific disciplines. And Kitz argues in this book that computational reproducibility is the ability of a second researcher to receive a set of files, including data, code, and documentation, and to recreate or recover the outputs of a research project, including figures, tables, and other key quantitative and qualitative results. So basically, if a research project is computational reproducible, it also means that it has a higher quality because it's not something that one researcher did one time and it's a unique event, but it's something that can be reproduced by others as well. So the results are reproducible and hence also work for others. Computational reproducibility also is something like a love letter to your future self, because it's not just about giving others the possibility to reproduce research results or your research results. It's also about yourself, of giving you the possibility to reproduce your research results in later, so in 2 weeks, in 4 months, in a year, or whatever. So that's also something that researchers often struggle to reproduce their own research at a later point of time. But there are certain challenges when it comes to computational reproducibility, and thankfully, but there are also solutions to these challenges. And I'm going to talk shortly about these challenges and these solutions. So the first challenge we come across with computational reproducibility is the fact that we often have multiple inconsistent versions of code, data, or in the worst case of both. So we do an analysis, we collaborate with colleagues, we work on code, and suddenly we do have different versions of the code, and we do not really know, okay, what is the actual version? Why did we come from this step to the next step? But there's a solution to this problem of inconsistency of versions of code. And that solution is so-called version control, or Git. That's what I use for storing all the scripts and files for this webinar. Another challenge is the often missing documentation and copy and paste errors in final reports. So sometimes we do not have a clear documentation of the code. We do not know why we used this function instead of another function, why we manipulated the data the way we did. And what also happens if we have if we do some analysis and we have some results, we copy and paste these results by just copy and paste into another document, for example, a Word document or a LaTeX document or whatever. But there's also a solution to this problem, and that is dynamic document generation or literate programming, for example, by using RStudio and Quarto, where we can put the analysis and writing reports in the same document. If you're interested in these two challenges and solutions, have a look at this Open Science and Reproducible Research course that we already did here. And it gives you basic introduction into how to work with Git and how to work collaboratively using Quarto and RStudio, for example. There are other challenges as well. And one of the other challenges is software dependencies, because research results often depend on the software or the environment where these analyses are done in. So for example, if you write in R code and you have R packages, these packages are sometimes updated. There are new versions of packages with new functions, with new options in functions, and hence this analysis are sometimes difficult to replicate or to reproduce because of new versions of software, new versions of packages. One solution, or the solution to this problem, is the concept of containerization, meaning to use, for example, Docker to somehow simulate a whole computational environment, or to use the renv-package. That's what we do today, to use the renv-package in order to save certain versions of packages for the analysis. And the last challenge, according to to Peikert and others, is undocumented or ambiguous order of documentation. That means, for example, you write a code, you have several scripts, but it's somehow difficult to see how these scripts fit together, how they have to be, in which order they have to be rerun. So the solution here is a clear file and folder management system, a lot of comments in the scripts that explain what you do and when to do what, or to create so-called make files, or in R, the targets package. And that's what we will do today. We will focus on these two challenges, that is how to tackle the problem of software and package dependencies with the renv package, and how to ensure that the scripts are executed in the right order using a pipeline tool, the so-called targets package. This has also something to do with the reproducible iceberg, as Rodriguez calls. Rodriguez argues that the parts of an iceberg that you can see are similar to the parts of reproducibility that you see. So the easy parts of reproducibility are the small parts of the iceberg above the water, but the main part of the iceberg is beneath the water, and the deeper you go down, the more challenging these approaches become, and the deeper you go, the more computational reproducible are things. So basically, if you work without the script, so just clicks for your analysis, so that's the top of the iceberg, you have research that is basically not reproducible at all, because no one can somehow track what you have done in your analysis. So the next step would be to have a script, but this script is undocumented and untested. It's something that works in a specific point of time, but I'm pretty sure that this script will not work, or it's quite difficult to work with this script for yourself at a later point of time, and it's quite difficult for others that that get access to this document, because it's undocumented and it's untested in different environments. So the next step would be to make the script available online, so others can have access to it, can have a look at it, and maybe discuss what you have done here. The next step would be not only to make it available online, but to put it on GitHub so that users can see your commit history, that they can somehow see how this code has evolved, how you came from one step to another step, and where all the problems came across. Then the next step, and we go one level deeper, would be the script is not just on GitHub, but it's also tested, documented, and it uses best practices to run on any machine. So you as an author have really tried to make this document or the scripts work on many other machines, and not just on your machine or your computer in a specific point of time. And the next step would be to surround your whole scripts with an infrastructure so that the dependencies are frozen using the renv package, and also to put your whole analysis into a pipeline that guarantees that the scripts are run in the right order, and the output is always the same. To go even deeper, you could use you could freeze your pipeline using Docker. So Docker, for example, is a computational, is a Linux system basically, where your pipeline is run always in the same system, independent of user's own machine. And if you go even one step deeper, that's quite challenging. You could use, you could make the whole computational environment even reproducible using GUIs. What we do today in the webinar is to focus on this level. So what we try to do is we really try to make our research reproducible by surrounding our script with a certain infrastructure. That is, we try to freeze the package dependencies using the renv package, and we try to guarantee the right execution or the execution of scripts in the right order with the target pipeline package. Okay, so let's start with the renv-package and package dependencies with the renv-package. So what is renv in the first place? Renv is an R package that helps you to create a reproducible environment for R projects concerning the packages needed for an analysis. So renv helps you as a researcher to freeze the current state of versions of packages in your project. So to guarantee that if someone is using or is trying to replicate or reproduce your research at a later point of time, that he or she, and maybe also you yourself, use the same versions of packages that you have done when you created the project. So this is important because sometimes or quite often packages develop, they evolve, there are new versions, there are some new functions. Functions have different options or different function names. This happened to me one time when I used the container package, and I used the code I was using a year before. And because of this update, I could not replicate my own code because the functions have changed. And I really had to invest a lot of time for rewriting the whole code. This would not have happened if I would have used the renv-package, because the renv-package just freezes the package version at a certain point of time. And how does this basic concept of renv work? As you can see here, these are the basic elements of the renv package, and you can see here the most common functions and commands of the renv package. And I'm going to explain to you here in this figure what they do, and then I'm going to show it to you the single steps of how to use the renv package. So basically, on your computer, you have, when you have installed R, you have a system-wide, a global-wide library where all the packages are installed. So whenever you install a package, these packages are installed in the system-wide library. And whenever you update a package, they are updated here. What renv does, it does with the command init, and I'm going to show to you this command soon. It initializes a project library. So it creates a second library on your computer in your R project. So hence you need, in order to use renv, you have to use RStudio and create an R project. With the command init, you create a project-specific library where all packages of this specific time, for this specific time, are saved in the project library. And whenever you install and whenever you are in your R project, where you have initialized renv, and you install or update libraries, they are always installed and updated in this project library. This project library takes so-called snapshots. Whenever you add a new package via the function snapshot, the use of this package and the version of the package are snapshotted, so are saved in a so-called log file. And with the function status, you can check whether your project library and the log file are up to date. When you come back to your project, or when you give this project to someone else, he or she can restore this project library with the information stored in the log file and the function called restore. So again, the basic concept or the basic idea of renv is to create a project-specific library where all packages needed are saved with the specific version number in a so-called log file that allows you later on to restore this project library and to recreate the same package environment that you used for your project in the first place. Did you get the basic concept? I'm going to show you how it works specifically soon. but that's the basic idea. So to create a project library and to save all the information in a log file that can be used then to restore this project library at a later point of time by yourself or by colleagues that clone your repository. Okay, so how does this work now in practice? The first thing is you have to install renv and you have to load the package, the library. And here's, that's what I did here. So it's a screenshot of my RStudio console. I installed the package and I loaded the package. As you can see here, and it's quite important, I installed this renv-package in the global library because it's the only library I have at the moment. So this package is stored in the global system-wide library. Yeah. The next thing I do, I have to initialize renv, and I do so with the command init or renv ..:= init. And now what's R doing here? It's linking all the packages into the project library. Okay, so there's a global library and it saves all the versions of these packages I'm currently using in the global library into the project library. As you can see here, for example, the package askpass is in a version of 1.2.1, and it's saved in a log file for later on, that when I use this project again, it will use the package askpass in a version of 1.1. And now you can see here, this renv file now created a new library. And this library is not the library before, this one, as you can see here, but it's a new library stored in my project folder. So the project folder is the I4NG _ reproducible workflows folder. And here is a new library. I'm going to show to you this library soon. What is also saved is the version of R. So this log file and renv were used with the version of R 4.5.0. That's just an information renv saves. So when you do, when you try to reproduce the research, you will not be able to install this version of R next to another version of R. So it just gives you the information, for example, that you're currently maybe using a newer version of R, but renv originally was used with version 4.5.0, and it's up to you to decide whether it makes sense to downgrade or to upgrade your R version. Okay? So now that we have initialized renv and that we've started renv in your R project, we can have a look at where are our package libraries. And we can do so by using the command or the function point_lib_path. This function just shows you which where the libraries are. And as you can see here, there are two libraries now in my R ecosystem. One is the library of my project. So it's again here, the library in my Infra for Next Generation Reproducible Workflows webinar. In the folder renv, and here's the library with all the information. And there's a second library, and that's the second system-wide global library I was talking before. And it's very important here to see the order of these libraries, because the first library is the project library, and the second library is the system-wide library. That is important because if you want to look for a package, for example, by using the function or the command find package, for example, to have a look where is tinyverse package, R or renv looks for the project library at first. And when it finds this package in the project library, it uses the project library. Otherwise, it looks for system-wide library, and then you would have this library as the research result. But again, tidyverse was already installed or initialized with renv in the project library, and hence it returns the project library as the first library, and hence it does not look further for other libraries. Now, what happens if we install other packages within the renv environment? So we have already initialized renv. We have an updated log file that mirrors basically the libraries, the packages you use in your project library. But now we install a new library called a new package called tidy models. What it does, it downloads the package and then asks you here after downloading all dependencies of this package, in this case tidy models, it asks you if you want to install this package into your project library. If you say yes, it installs these packages, in this case 42 packages because of the dependencies of the tidy models package, into your project library. With the command status, so renv status, you can have a look, what I did here, if there are any issue or inconsistencies between your log file, your libraries, and all the dependencies. What does dependencies mean? renv is a great package because renv automatically scans all R files in your project folder. And if it finds any package there that you try to load with library or require or even pload from the pacman package, it gives you the information that the status of your project is not up to date, because there are some packages that are not in the log file, or that are in the log file but not installed in the library, or there are some packages in the scripts, but they are neither in the library nor in the log file. With the command snapshot, you can basically update the log file. So you basically say, okay, now take a picture of the current project library and put this information into the log file. I've done so here, but there's the log file was already up to date, so there was no need to make another snapshot. What is interesting here, I also said, okay, find the package tidy models I installed here, and this tidy models package was installed in this project library. The interesting thing here is, if you close RStudio and you then reopen RStudio, but not this project, you will not have access to tidy models, because tidy models now was only installed in the project folder, but not in the system-wide folder. So if you rerun your code without starting the R project, tidy models will not be found because it's in a project library and you haven't loaded this project library yet. There are other important functions of this you can use. There's, of course, the update function. That means, for example, at the end of the day, if you have finished your project and you want to update the packages to the current, most recent version, you can use just the command renv update, and all the packages are updated to the current version. What is important here, if you do so, please rerun and check the code afterwards if it's still working. And then if you somehow recreate your project, or if you share it with others, these people, yourself at a later point of time, can restore this project library with the command restore. So by renv restore, it installs all the packages that are saved in a log file on your current project. What is also important is that when you share your renv, your project with renv on Git, you do not have to copy all the libraries and additional other information on the Git, because it's a lot of data that you would push up to the repository. You can add this information to your Git ignore, because the only thing you need basically is the log file, and the log file is nothing else than a text file that lists all the packages with all the versions and dependencies that you use in your renv package. And by using renv restore, it uses this information of the log file to download the respective versions to your project, and you don't have to push them on the Git as such. So I would suggest adding these elements to your git ignore file so that they will not be pushed onto the repository. So basically, that is all you have to know about renv, and these are the basics for using renv. So what happens if you open or reopen your R project? It's quite easy, because if you open your R project where you used renv, it automatically loads this renv, this library, and renv in version 1.1.4. And why does it do so? Because in this project file, in this R project file, there's the file R profile, and this R profile file sources the activate R script in the renv subfolder, and this activate R script automatically loads this project library automatically. So it guarantees by opening this R project, it guarantees that you always work with the same or the right versions of the packages that you needed or that you used for your analysis in the first place. So overall, our renv is quite easy to use and really efficient. But it's not only for sharing R scripts with others, but mostly for reusing your own scripts at a later point of time. So if you do some analysis in 2 or 3 months, and there are some updates in packages, there are new versions, it guarantees that the analysis will be the same as before, at least when it comes to package dependencies. Okay, so the Git I share with you has already this renv project initialized there. So if you clone it there and you open your project and you enter the code for renv restore here, this one, it should automatically download all the packages that I was using here in this project library. Okay, good. So let me go on with the second tool of today's webinar, and maybe save questions for later. Or are there any urgent questions you want to ask concerning renv? If not, let's go on with pipelining with targets. Targets is a pipeline tool in R to coordinate computationally demanding projects. And with computationally demanding projects, I mean projects that we can split into different analytical steps, and where these steps build on each other, and where all these steps take some time and some computational power to run these scripts. You use targets basically if you do not want to have all the scripts run every time you make some changes, but you only want to have those parts rerun that have changed, or that are somehow dependent or the foundation for other scripts. I linked 2 very important sources to learn the targets package. That's on the one side here, the targets user manual by Will Landau. You can see here it's easy to read with a lot of information, and especially it goes even more into detail, more than I do today, because I will not talk about distributed computing, for example. But it's basically all here. And there's also a quarter presentation of Will Landau on this topic, and you can have access here to this, presentation here. Let me first explain to you why you should use target, and then also tell you why you should, when you should not use target. Because target is a really nice and efficient and powerful tool, but it's not something you use on a daily basis and for every research project. So basically, you use targets if you need a pipeline tool for statistics and data science in R, similar to the to makefiles in GNU. When you have, maybe you've heard about this one. You use it if you have to coordinate the pieces of computational demanding and analytical projects. That is what I was talking about. And when the steps of analysis have to be repeated multiple times, so often you do some analysis, but you have to rerun these analysis because you have to adapt some code or rerun parts of the code or whatever. And the more often you do this, the more handy it becomes to use the targets package. And it's extremely handy package to make your analysis reproducible. So to give others your code, and the other people just use one command to rerun your whole code instead of having a look which script to run first and which script is dependent on what other scripts. You do not have to use it for simple analysis. So if you have really a basic simple analysis, just like analysis I'm going to show you today, you don't have to use targets. But I, of course, use a simple script in order to show you how targets works. But basically, if I would have done this script just for me, I would not have used targets at the end of the day. But this shows you how to use targets at the end of the day. So a precondition for the use of target is function-oriented style of programming. So targets expects you as a user to adopt a function-oriented style of programming. I linked here this chapter in the targets manual that explains to you very detailed what a function-oriented style of programming means. Basically, it means you have to convert your whole script into several functions, which is not that difficult at the end of the day. So targets needs functions that are organized according to at least 3 steps of analysis. First step is data generation. So how do you get your data? Data analysis. So how do you model or analyze your data? And how you report your results or how you plot your results. Of course, these are at least 3 steps. It could be more steps. For example, if you say, okay, you have a function on how to get the data, then you have a function of how you manipulated the data because you did some quite fancy manipulating stuff, and so on and so on. Okay. And you save all these functions in a subfolder called R in your R project directory. This subfolder does not have to be named R, but R is the predefined subfolder. So I would suggest you to use a subfolder called R, but this subfolder can be named with the way you like. So the precondition for targets to be used or to work is that you transfer your script, your original script, into several functions, and you save these functions into a subfolder called R or any other name, but then you have to somehow adapt the code at the end of the day. So let's do this. I have written a script. I'm gonna explain to you the script in short steps. What I do here, I use, of course, in my scripts a lot of comments in order to have an overview of the script. That's why I use here, for example, configuration with 3 minus. That means in RStudio, I have a table of contents with configuration, loading data, analyzing data, and so on. I load the package tidyverse. I install the package tidyverse. I load the package tidyverse. I use data from Kronos, the second wave. and I save this data in the data folder and use the read CSV function of tidyverse and save it to the R object data frame. I have a look at the data frame, and then I select two variables for our analysis. And these are two variables from the Going Green part of this Kronos data set. It's first the variable W2GQ1. It's a weird variable, but it's a question: how worried are people about climate change? And I use a second variable. It's with 2GQ6. Humans are meant to rule the nature. And I will use these two variables for asking a very simple question: is there a relationship between people's being worried about climate change and about their belief whether men or human beings are meant to rule over nature? I do some data manipulation here. So I select these two variables plus another variable, that's the variable age group. So it's a variable that basically divides the participants of this survey in people from 18 or something until 35, and those 35 and older. I do rename the variables because it's quite difficult to work with a variable that is not really identifiable. So I rename the variable W2GQ1 to climate and the other variable to rule. I remove the no answers in all the three variables. And what I also do, I recode the answers in the variable humans meant to rule over nature, so in rule, because to have a similar direction as the variables on climate. So agree strongly becomes 5 and disagree strongly becomes 1. So it makes sense at the end of the day. It's more logical if you combine both variables. And I also mutate the age group variable. I mutate it to a factor and I recode it and say, okay, those with 1 are under 35 and those with 2 are 35 or above. Then I analyze the data. I fit a very, very easy and basic model, let's say a linear model where climate is dependent on rule, and I summarize it. And I now plot the results. I plot the model. So the model includes including the intercept and the slope. And I make a violin plot, having a look if there is a group difference between the age group when it comes to how worried are people about climate change. So that's the basic script I would use. And to be honest, I would use this script, or I would not program it in a different way if I would just have done this analysis. But for demonstrating the use of targets, now let's transfer this script into targets functions. Okay. So the first thing is how to get the data. That is this part of the data set. It's loading the data and it's manipulating the data. It's quite easy to do that. I create a new file called 01_data.r. And here I create a function called getData. And it's a function where I have an input file and then basically have the same code on this side as I have here, okay, where I put everything into this function. And at the end of the day, with this function, I can get the data, I load the data, and I manipulate the data just as I did here. The next function is even more easier. I save this function into the R file 02_analyze.r, and I call this function fit_model, and I use the data and create a new function where I have climate change is dependent on rule, and these variables come from the object data. And the final functions are saved in the file 03_plot.r. And here I have two functions, a function called plot model and a function called plot violin. The first function is a function where I use the data and the modal. So things I created before, and I do some plotting here with ggplot. And in the violin plot, I just use the data and the plot here, age group and on the x-axis and climate on the y-axis. And I do a violin plot with some color ring and some labels here. Okay. So again, I just transfer this. The script into functions, which is not that difficult. So these functions now are the precondition for using targets. And I'm going to show you now how you really use targets at the end of the day. The first thing is you install a targets package, and you also should install another package. I'm going to tell you why you need this other package soon. Okay, so for using targets, you don't have to use the target types package, but it's very important for another application of targets or combination of targets with something else. But I will come to this later. So I install it, and as you can see here, it's still in our project, and it's in and because I have initialized renv here, it is installed in this renv project library, as you can see here. Now it is installed in the project library. The next step is you load the targets package, and you use the use targets function. And this is extremely easy to use function because that's all you have to do in order to initialize or to start the targets package. Because what is done now, use targets also installs another package, the use this package, because it's required for the use targets. As you can see here, again, it's installed in the renv library, but it creates a targets underscore targets point R document. And it tells you now at the end of the day, please modify this underscore targets R. So that's basically all you have to do. You just use the use targets. You load targets with library, and you create the targets point R file, underscore targets point R file, with the command use targets. And then target says, okay, now I've created this file. Please modify this file. Let's have a first look at this file, how it looks like after targets created it. And as you can see here, it's a file with a lot of comments. So it's really, really perfectly commented, so that you can just by reading these comments work with this file, and you can adapt the file as you wish or as needed. I did so here in this case. So that is basically the underscore targets R file that are now adapted for my needs. What I do here, I load, the first thing you do here in the targets package, you load targets. And again, target types, but I'm going to explain to you later why. Then you set the targets options. And basically what you do here is you load all the packages that are needed in the functions. So whenever you need the packages in the functions, you have to tell targets here in target option set which packages you need. And it's quite easy. You just say packages equals, and then you just mention all the packages here in this vector. You could also, for example, you can see this one here. You could also, for example, use the distributed computing with the crew option, for example. So, for example, if you have computational demanding processes, you can use the crew package so that these different steps of analysis are done at the same time if possible. So you can do basically run several scripts at the same time in parallel. So it's basically parallelization. I've not done it here because it's a quite easy analysis here. The next thing you do is you have to source all the scripts in the R folder. And that's the reason why I told you, please save your functions, your scripts, and the functions in the scripts in the R folder, because with tar source, it automatically runs all the R scripts in the R folder. Of course, you could say here tar source and then say, okay, the file is not R, but any other folder, maybe function or whatever. But by saving them just in the R subfolder, you just have to use tar source, and all the R scripts are now run with all the functions in there. And here's the central element now. What you do now, you just make a list of all the targets you need in your pipeline. I'm going to explain to you these targets now in step by step. The first target is called file. What you do here is you create a new R object, and these R objects can be used within R as any other object. This first object is called file. It reads the CSV file, and it formats the format. The option format is file option. Why? Because you can see here there's no other format defined here, just here for the file. That means it always checks whether this file that you put in here has changed when you run your pipeline the last time. So by adding the format equals file, this CSV file is always targets always checks whether the CSV file has changed or not. If not, it will not be loaded again. Okay. Then in the next targets, you create a new R object called data by using the getData function and the file you were defining here. Then you create a new R object called modal using the fit-modal function and the data, so the object you created before. Then we create a new R object called plot using the plot modal function and using data and modal objects created before. And then we do the violin plot. We create a violin plot object using the plot violin function and using the object data created before. So basically what we do here, we create our objects as targets, so-called targets, by linking the functions in the R folder with input that we created here. Okay. So the next thing we do is, or now we have defined our targets in our pipeline. So we loaded the package, we set the options for running the functions, we sourced the functions, and we created a list of all R objects, of all targets that are used in this pipeline. And now we don't have to, but we can have a look at this pipeline by using the function tar_with_network. Tar_with_network now gives us an overview of this pipeline. And as you can see here, we have functions. These are these triangles. And we have targets. These are the circles. And as you can see here, the object data is created by combining the target file with the function getData. Data is then used in combination with fit-modal to create the modal. And the modal is then used to being plotted with the function plot model and in combination with data and model. And violin plot is done via the function plot violin together with data. So you can see basically how these different functions and the different targets, the R objects, work at the end of the day. What is also important, as you can see here, all these functions and targets are outdated because we have not run the pipeline yet. That's what we do now. And that's the great thing of targets. You don't have to run every script and every function of their own. You just have to use one single command, and that's the tar make command. Tar make is the magic command, the one that rules them all, so to say. And when we start this, the pipeline is run by targets. So it creates data, it creates the violin plot, it creates the model, and it creates the plot based on everything before. So after 689 milliseconds, the 4 targets are completed and one has been skipped. Yes. So basically, it's all these data, violin plot, model, and plot are, at the end of the day, R objects that can be used in R from now on. And how do you use it? It's quite easy, just with the function tar read. With tar read, you can read every single object that we've defined here in our pipeline. For example, when we use tar read model, we get the result of the model. Okay? That's basically nothing else than the model we did before, and that's the output of the model. Okay, so what happens now if we somehow changed a function because we didn't like the plot, we wanted to have a different color of the plot? That's what we do here, for example. Okay, so in a function 3 underscore plot R, we change here the color from a nice color to a very ugly color. To be honest, I should have done it the other way around, but sorry for this. So I changed the color here in the function plot model. Okay. When we have a look again with tar this network, you can see here that the function plot model has changed. So all other functions and targets are up to date, but not the plot model because it has changed. And because this function has changed, also the target plot has changed or should have changed. Okay. So as you can see here, your whole pipeline is not up to date, or certain parts of your pipeline are not up to date. 3 functions are up to date, and 1, 2, 3, 4 targets, but 1 function and the dependent target are not up to date. So when you go, it's quite easy to change that. Just use this magic command, tar make, and tar make now recognizes, okay, there's 1 function not up to date. So it reruns this function and creates the new object called, or the new target called plot. And we can read this new target now. And as we can see here, okay, the color changed from, I think, blue to this yellow version. Okay. So this is an example that is not really computational demanding, but think about an analytical step where one of these function changes, but you don't have to rerun all the other functions. Of course, you could say, yeah, maybe I'm used to number my scripts in the right way, and hence I never rerun the whole code. Yeah, maybe that's true, but sometimes if you have bigger scripts, these scripts somehow depend on results that you save in R objects at an earlier point of time in other scripts. And this ensures you that it's always up to date and that you don't have to rerun scripts that are already up to date. And it's also something, if you, for example, do coding and if you are experienced in coding, you may have come across this issue several times. And you save something, you go home on the next day, you start going on with your coding. Maybe you don't know where you have stopped. By just using the tar make command, you can see where which parts of the code you already up to date and which parts you have changed and should be rerun. Let me give you one last advice, and that's the combination of targets and Quarto. And that's where targets becomes really, really powerful, because when you have used Quarto before and you did some analysis in Quarto, and this analysis may be even quite computational demanding, and then you recognize, okay, there's a spelling error somewhere in the Quarto document. You change this, you correct this spelling error. Whenever you render your Quarto document, the whole analysis has to be re-rendered and rerun. And that's where target comes in, and that's where this target types package comes in. So in this case, I created a Quarto document, a very simple Quarto document, where I included code chunks. In the first code chunk, I load the targets package, and I access the model and I access the plot by just using the tar read function as shown before. Okay, that's the same function I use here, tar read plot. By doing so, I can access the target model, and I can access the target plot in this case without repeating the whole code and doing the whole analysis again in this one. So with targets, I can access these R objects quite easily without rerunning the whole analysis. So I created this new file. This file is called report.qmd. And now I change the targets R file that is used for tar make afterwards for rerunning the script. So that's the reason why I need target types, because with target types, I can include Quarto documents into my list in my pipeline. And the second thing I've changed here, as you can see here, it's not just tar targets, but it's tar Quarto. That's the function that comes from the target types package, where I say, okay, at the end of the day, create a new report based on the file report.qmd. That's all I have to do. Just include another line in the list. I make a new target, but it's a Quarto target called report, and I link to the report file I was creating here before. So that's the report.qmd file. And now I just have to use our magic command again, tar make. Everything is up to date except report. The report is completed. It takes some time in this case because it's done for the first time. And as you can see here at the end of the day, the report looks as such. I can just read the model because it's already up to date and saved in my targets subfolder. And I can also read and display the plot of the model in my Quarto document. So again, if there was any spelling mistake, and by changing it and rerunning or again using the tar make command, targets would have noticed, okay, this report is changed, so it reruns the report, but it does not have to rerun the model as such and the plot because they have not changed yet. Okay, so basically that's what I was trying to do in the last 17 minutes. In the bibliography, please have a look at these books and papers. All the books and all the papers are open access, at least the book of Kitzes, the book of the manual of Landau. The same is true with Rodriguez and the renv-package environment documentation of Ashe and Hadley Weekend. Before we come to the questions, let me give you some recommendations of upcoming events. There will be an Info for Next Generation hackathon, analyzing Kronos data and communicating key insights to policymakers from June 11th until June 16th. Registration is still open, and there will be a webinar by Lisa and Julia on data-driven insights for green, digital, healthy, strong, and equal Europe. So if you're interested in these topics, please have a look at it. I put the links in here in the presentation. And again, the presentation will be available via Git. A quick reminder, please give us feedback to this webinar. So when you close your Zoom meeting at the end of the day, you will get a link to this feedback. Please use it. We take these feedbacks very seriously. And now I'm all yours. Please give me your questions, and I'm really curious what you think about it. When I do, for example, quantitative text analysis, and I do have a pipeline where I do a lot of pre-processing. Pre-processing is something I always have to redo, because then I recognize in my analysis, okay, I missed some words or some terms that I have to go back to rerun certain parts of the code. That's where targets is quite powerful, because not all parts of the code are dependent on or depend on this pre-processing that I did before. It depends on the corpus and the pre-processing things I do, but that's where it comes quite handy to do things. Or if you do some analysis, and this analysis is, as you can see here, the violin plot that I didn't show to you here is just based on data, but not on the model. Okay, so I do the violin plot just on data, but it's not dependent on the results of the model. So when I change the model, I don't have to change the violin plot at the end of the day. So there's no dependencies on this plot, so I don't have to rerun the whole plot again. Okay. It's quite nice to do it when you use Quarto. That's where I often use it, because if I do, for example, teaching, and I show students certain plots, and I need some data manipulation before, and I have quite a large Quarto document, and I render it every time. All the data manipulation, all the plots are done every time and every time again. It's quite a lot of time that I need. And with targets, I just include those objects with the tar read in my document, and it's just rendered. It only takes time for rendering the text, but not so much the R objects manipulating data and so on. Of course, the more difficult, the more complex a code becomes, the more demanding it is to transfer this code into functions. But again, I have to be honest. If I do certain plots, and I use ggplot, and I try to recreate a certain plot that has maybe 200 lines of code, to transfer this code into a function is also something that's quite challenging at the end of the day. Okay, so I would suggest you to take a very simple project, try to use targets once, and then think how handy this package becomes for more complex analysis. Okay, because you really have to rethink the way you do your programming, because you have to have functions in the first place. And to create functions is not that difficult, as you can see here. It's just creating a new R object and say, okay, that's a function, and then copy basically the script into this new function. But again, you have to, and that's something that is not convenient in the first place, but very, very important. You have to rethink your whole script by dividing the scripts into analytical steps and into functions. And I think this is something that is very, very useful at the end of the day. If you have not done coding like this before, because everyone starts coding the way he or she has done it before, and we learn, and then we add something, and then we add something else, it becomes quite easily, or it becomes quite messy at the end of the day. And by this functional programming, you are forced to to divide your code in analytical steps and to divide these analytical steps into functions that make sense. And of course, you have to think how big this function should be. Do you have a view but big functions, or do you have many functions that are quite small so that you, when you change a function, that you don't have to rerun a whole function, but only parts of a function? That's also something that you learn by just doing it.
There is another question in the chat. It's, can one go back to the older versions of the packages after using renv-update, for example, if it broke your code?
No, I don't think you can. I have not thought about it. I mean, if you use renv and you use git, okay, you can, because then you can use an older commit to go one step back. But as soon as you use renv update, the log file is being updated to the newest version. And this should have deleted the information of the older versions. I don't think that there is a history in renv. To be honest, I can check this, but I don't think it works. If you combine renv with git, it's quite easy to do. Yeah, and if you use renv or targets in the future, or just give it a try, give it a look, I think it's worth doing it. Thank you.
Thank you.